As we all know, in previous SAM we have learned partial differentiation. In partial differentiation we have one dependent and more than one independent variable. In this SAM we have to learn all about partial differential equation. So let's start with definition. The equation which has partial derivatives, independent variable and dependent variable are known as partial differential equation. For example, del z by del y equals to e raised to minus x, where z is dependent variable and y is independent variable, and e raised to minus x is any function. Similarly, we have another example, del 2z upon del x del y equal to x square y, where again z is dependent and x and y are independent variable. So the notations are, when we use in PDE, del z by del x equals to p, del z by del y equals to q, del 2z by del x square equals to r, del 2z upon del x del y equals to s, and similarly del 2z upon del y square equals to t. Whenever we use del z by del x, we use p, and the other term p, q, r, s, t are also used similarly. The order of partial differential equation is same as that of the order of highest differential coefficient present in it. So for example, del 2z upon del x del y equals to x square y is second order partial differential equation, and the other one, del z by del y equals to minus x, is first order partial differential equations. So now the other thing is formation of partial differential equation. So how we form PDE? The first method is eliminating by arbitrary constant, and the another is by eliminating arbitrary function. So let's see the first function, method of elimination of arbitrary constant. In this method we eliminate all the constants which is present in the function by partially differentiating with respect to independent variable, and then we form partial differential equation. The first example is form a partial differential equation from x square plus y square plus z minus c whole square equal to a square. So now let's start with partially differentiating with respect to x. The partial differentiation of x square is 2x. The partial differentiation of y square with respect to x is 0. And z minus c whole square is 2z minus c del z by del x equals to 0. On simplifying, we get x plus z minus c p equal to 0. Again differentiating equation 1 with respect to y, we get another equation 2y plus 2z minus c del z upon del y equals to 0. So here we have two equations where we have common term is z minus c. We eliminate z minus c between these two equations and we get yp minus xq is equal to 0 is partial differential equation, where small p is del z by del x and small q is del z by del y. Now the another method is by eliminating arbitrary function. In this method we eliminate a common function between two terms. For example, we have a function z is equals to f x square minus y square. So here we don't have any constant, here we have only a function. So just start with partially differentiating with respect to x, that is del z by del x, and the notation of del z by del x is small p. Now when we differentiate partially with respect to x, we have f dash x square minus y square, and the partial differentiation of x square minus y square is 2x. Similarly, we get del z by del y and denote it by q. So we see here p and q, there is a common function f dash x square minus y square. We just divide both the terms and get yp plus xq is equal to 0 by eliminating a function. So these are the two methods by which we can form partial differential equation. That's it.